The morning sun cast long shadows across the Galactic Academic Exchange campus as students from dozens of worlds hurried to their classes. The massive complex floated in orbit around Kepler 442b, its transparent walls offering breathtaking views of the planet below. Inside classroom Beta 7, 32 graduate students settled into their seats, preparing for another lecture on advanced engineering principles. Professor Zixthala entered the room with her usual dramatic flair. The Caridian stood nearly 8 feet tall, her 4 arms moving independently as she arranged her teaching materials. Her species had evolved from insect-like creatures, and even after millions of years of evolution, she retained the clicking mandibles and compound eyes that made many other species uncomfortable. Her reputation as the most demanding professor in the engineering department preceded her wherever she went. Today we examine the transportation methods of primitive civilizations, she announced, her voice carrying the mechanical tone of the universal translator. Specifically, we will discuss why certain species develop crude physical construction techniques rather than pursuing proper mathematical modeling. The students shifted in their seats. Most were from highly advanced species that had developed space travel through careful theoretical work and computer simulations. The idea of building anything with their own hands seemed foreign and unnecessary to them. Jake Morrison sat in the back row, as usual. At 24 years old, he was one of the youngest students in the program and definitely the most out of place. His brown hair was longer than regulation allowed, and his casual clothes contrasted sharply with the formal attire worn by his classmates. As the only human in the advanced engineering program, Jake had grown used to being treated as a curiosity rather than a serious student. The human exchange program had been controversial from the start. Earth had only achieved interstellar travel 50 years ago, making humans relative newcomers to galactic civilization. Many questioned whether a species so young could contribute anything meaningful to advanced academic institutions. Professor Zixthala activated the wall display, showing images of various primitive watercraft from different worlds. Crude rafts, simple boats, and basic sailing vessels appeared in sequence. Each image drew chuckles and dismissive sounds from the alien students. Observe these examples of inefficient design, she continued. Notice the complete absence of stress analysis, the lack of optimal material distribution, and the primitive joining techniques. These constructions represent the fumbling attempts of species that have not yet developed proper engineering mathematics. Jake raised his hand. Professor, those boats actually worked pretty well for their intended purposes. Some of those designs are thousands of years old and are still being used today. The classroom fell silent. Professor Zixthala's 4 eyes focused on Jake with obvious irritation. Mr. Morrison, efficiency is not measured by longevity, but by optimization. These crude assemblages may float, but they represent wasted materials and inefficient use of resources. But they got people where they needed to go, Jake replied. Sometimes that's more important than perfect optimization. A student from Centauri. Prime made a sound that the translator rendered as laughter. Typical human thinking. Why solve a problem efficiently when you can just throw more materials at it? Professor Zixthala raised one of her hands for silence. Her mandibles clicked together in what Jake had learned was a sign of deep thought. Suddenly, her compound eyes brightened with what could only be described as malicious inspiration. Since Mr. Morrison seems to believe in the value of primitive construction methods, perhaps he would like to demonstrate their effectiveness, she said. I hereby issue a challenge to the entire class. She gestured toward the massive windows that dominated one wall of the classroom. Beyond the transparent barrier lay an artificial lake, part of the campus's environmental simulation area. The lake stretched for nearly 2 kilometers, its surface dotted with small islands and bordered by carefully maintained wilderness areas. Using only the materials available in Survival Simulation Area C, any student may attempt to construct a functional watercraft. The challenge is to build something capable of safely transporting 3 individuals across the entire lake and back. The students looked at each other with expressions ranging from confusion to amusement. Most had never built anything more complex than a computer model. The idea of working with actual physical materials seemed absurd. "What materials are available?" asked a student from Vega 7. "Basic cutting tools, rope, raw timber, metal scraps, and various discarded components," Professor Zixthala replied. "Nothing that requires advanced manufacturing or sophisticated technology. Exactly the sort of primitive resources that Mr. Morrison's species seems to favor." Jake felt his heart rate increase. He could sense that this was more than just an academic exercise. Professor Zixthala was trying to humiliate him and, by extension, prove that human engineering methods were inferior to advanced alien techniques. "You have 26 standard hours to complete this task," she continued. "Failure to produce? A functional vessel will result in a detailed analysis of why primitive construction methods are inadequate for serious engineering challenges." The implication was clear. If Jake failed, it would be used as evidence that humans didn't belong in advanced engineering programs. If he succeeded, it would be dismissed as a fluke or credited to luck rather than skill. Jake stood up slowly, his mind already racing through possibilities. He had spent summers working with his grandfather, a retired boat builder from Michigan. Those long afternoons learning to work with wood and rope suddenly seemed more valuable than any theoretical knowledge he had gained in formal education. "I accept your challenge, Professor," he said. His voice steady despite the adrenaline coursing through his system. The classroom erupted in excited chattering. Students from various species began placing bets on the outcome, with most wagering that the human would abandon the project within hours. A few expressed concern that Jake was walking into an obvious trap. Professor Zixthala's mandibles curved upward in what passed for a smile among her species. "Excellent, Mr. Morrison. I look forward to observing your primitive construction techniques in action." Class dismissed. Those interested in witnessing this demonstration should report to Observation Deck 7 tomorrow morning. As the students filed out of the classroom, Jake remained seated, staring out at the lake that had suddenly become his greatest challenge. He had 26 hours to build something that would either validate human engineering or confirm alien suspicions about humanity's limitations. The weight of representing his entire species pressed down on him like a physical force. His roommate Alex Chun appeared at his side. "Jake, you don't have to do this. Everyone knows she's trying to set you up for failure." Jake finally stood and gathered his materials. "Maybe she is, Alex, but sometimes the best way to deal with a challenge is to meet it head on. Besides, I've got an advantage she doesn't know about." "What's that?" Jake grinned as they walked toward the exit. "I actually know how to build things with my hands. That's something you can't learn from a textbook." Dawn broke over the artificial lake as Jake stepped into survival simulation area. The morning air carried the scent of pine and fresh water, reminding him of childhood summers at his grandfather's workshop. Behind him, the observation deck was already filling with curious students and faculty members, all eager to watch what many expected to be a spectacular failure. Jake ignored the growing crowd and focused on the task ahead. The simulation area covered roughly 5 acres of carefully maintained wilderness. Ancient-looking trees dotted the landscape, some fallen and weathered, others standing tall with thick trunks. Scattered throughout the area were various materials left from previous survival, exercises and decommissioned equipment. He spent the first hour walking methodically through every square meter of available space, while the aliens watched from their comfortable observation deck. Jake cataloged each resource with the practiced eye of someone who had learned to see potential in discarded materials. His grandfather had always said that good builders weren't the ones with the best tools, but the ones who could make something useful from whatever they found. Near the lake shore, Jake discovered several fallen logs of different sizes. The largest ones were nearly 3 feet in diameter and 20 feet long. Years of weathering had stripped away most of the bark, leaving smooth, dense wood that felt solid when he knocked against it. These would form the backbone of whatever he built, moving. Deeper into the area, he found coils of plant fiber rope hanging from storage hooks. The rope was thick and strong, designed for survival training exercises. Jake tested several sections, pulling hard to check for weak points. Most of it seemed sturdy enough for construction work. A pile of metal brackets caught his attention near an equipment shed. These pieces had been salvaged from some kind of orbital structure, their surfaces scratched and dented but still structurally sound. Jake picked up several different sizes, testing their weight and examining their connection points. With some creative thinking, these could serve as crucial joining elements. The tool selection was basic but adequate. Hand saws, axes, hammers, and simple cutting implements lay organized on workbenches. Jake had expected more primitive conditions, but these tools would allow him to shape materials with reasonable precision. A small welding setup in the corner of the shed surprised him. It was clearly intended for emergency repairs rather than construction, but it opened up new possibilities. The most interesting discovery came when Jake explored a storage area behind the main shed. Sheets of discarded polymer packaging material were stacked in neat piles, apparently waiting for disposal. The material was tough, flexible, and completely waterproof. Jake held up one sheet to the light, noting its thickness and durability. This could solve several problems he had already begun anticipating. Alex Chan arrived just as Jake finished his initial survey. The observation deck now held at least 50 spectators, including Professor Zixtala and several department heads. Word of the challenge had spread throughout the campus overnight. "The entire academic board is here, Jake," Alex said, glancing nervously at the watching crowd. "Professor Zixtala has been using this exact challenge for 3 semesters straight. She keeps detailed records of every failure. Nobody has even come close to building anything that could actually float properly." Jake knelt beside the lake and scooped up a handful of water, letting it run between his fingers as he thought. "That's because they're all approaching this like textbook engineers. Alex, they want to calculate load distributions and design optimal hull configurations before they even touch any materials." He pulled out a stick and began sketching rough designs in the sandy soil near the water's edge. "Look at what we have here. Good timber, strong rope, metal connectors, and waterproof sheeting. I don't need to build the perfect boat. I just need to build something that works." The design taking shape in the dirt was surprisingly simple. Jake outlined a catamaran configuration using the 2 largest logs as parallel floats. A platform deck would connect them, creating a stable base for passengers. The whole structure would be lashed together with rope and reinforced with the metal brackets. "A catamaran?" Alex asked. "Isn't that pretty advanced for primitive construction?" Jake grinned and continued sketching. "Catamarans are actually one of the oldest boat designs in human history. Pacific Islanders were building them thousands of years ago using nothing but wood, rope, and basic tools. The design is simple but incredibly effective." From the observation deck, Professor Zixtala's voice carried across the water, amplified by speakers for the benefit of the watching crowd. "Note how the human begins with crude drawings rather than proper mathematical analysis. This demonstrates the fundamental weakness of primitive construction methods." Several alien students made sounds of agreement. Jake could hear them discussing stress calculations and hydrodynamic modeling as if those concepts were essential for building a simple boat. "Professor Zixtala made one critical mistake," Jake explained to Alex as he refined his design. "She assumed I would try to impress everyone by building something complex and advanced. Instead, I'm going to build something that actually works." Jake pointed to different elements of his sketch. 2 logs for buoyancy and stability, a rope and wood platform for the deck, metal brackets at stress points to prevent the lashing from slipping, polymer sheets to waterproof the joints, and maybe create a simple sail. "What about steering?" Alex asked. "I'll carve a simple rudder from one of the smaller pieces of wood. Nothing fancy, just a flat surface that can be angled to control direction and propulsion." Jake looked up at the morning breeze rippling across the lake's surface. "The wind is pretty consistent here. I can rig a basic sail using the polymer sheeting and some of the longer branches. If the wind dies, we can always paddle." The simplicity of the plan seemed to worry Alex more than reassure him. "Are you sure this will work? I mean, you're basically planning to build a raft with a sail." That's exactly what I'm planning to build, Jake replied, standing and brushing dirt from his hands. A functional raft that can safely carry 3 people across a lake and back. Professor Zixtela asked for a watercraft that works, not one that wins design awards. From the observation deck came the sound of more aliens arriving to watch the humans' attempt. Jake could see them pointing at his simple tools and shaking their heads in apparent disbelief. Some were already recording the event, no doubt planning to use it as an example of human limitations in their own academic work. Jake rolled up his sleeves and selected his first tool. Time to show them what human engineering actually looks like. Alex, this isn't about perfect calculations or optimal designs. It's about understanding materials, recognizing what's possible, and having the practical skills to make it happen. He hefted the axe and approached the first log, already planning his cuts. The real work was about to begin, and Jake intended to prove that sometimes the best engineering came from experience, intuition, and the willingness to actually build something with your own hands. The first axe blow echoed across the lake as Jake began shaping his chosen logs. By now, word of the humans' boat-building challenge had spread throughout the entire academic complex. Students abandoned their morning classes to crowd onto the observation deck, while professors delayed their lectures to witness what many called the most entertaining academic disaster in recent memory. Jake paid no attention to the growing audience. He had work to do, and 24 hours was not nearly as much time as it might seem. The first task involved selecting and preparing the 2 main pontoons for his catamaran. He chose logs that were roughly the same size and weight, knowing that balance would be crucial for stability on the water. Working with steady, practice strokes, Jake stripped the remaining bark from both logs and began shaping their ends. His grandfather had taught him that water flowed better around tapered surfaces, so he carefully carved pointed bow sections on each pontoon. The work was slow and methodical, each cut planned to create the smoothest possible water entry. "Look at the human's technique," Professor Zixtela announced to her colleagues, her voice carrying across the area through the observation deck speakers. "Notice the complete absence of measurement tools or geometric verification. He simply cuts wood based on visual estimation." Several alien students made clicking sounds that their translators rendered as laughter. A tall, silver-skinned student from Rigel Beta leaned forward to get a better view. How can he possibly achieve optimal hydrodynamic efficiency without calculating the ideal hull-to-length ratio? Jake heard the comments but continued working. After 2 hours of careful shaping, both pontoons showed clean, smooth lines that would slice through water efficiently. He tested their balance by rolling them into the shallow water near the shore. Both logs floated high and stable, exactly as he had hoped. The next challenge involved creating the connection system between the pontoons. This was where Jake's discovery of the metal brackets would prove crucial. Using the primitive welding equipment, he heated several brackets until they glowed red-hot, then carefully bent them into custom clamps that could grip the curved surfaces of the logs. The welding work attracted more attention from the observers. Many alien species had moved beyond manual metalworking millions of years ago, preferring automated manufacturing processes. Watching Jake shape hot metal with simple tools seemed to fascinate and horrify them in equal measure. The structural stress calculations alone should require several days of computer modeling, commented Dr. Valtar from the physics department. How does he expect to verify the load-bearing capacity of those improvised connections? Jake wiped sweat from his forehead and looked up at the observation deck. "I don't need to verify them, Dr. Valtar. I need to build something that works. There's a difference between perfect engineering and good enough engineering." This response caused a stir among the academic observers. The concept of good enough engineering seemed to offend many of them on a fundamental level. Their cultures had spent millennia perfecting theoretical approaches that eliminated guesswork and uncertainty. Lisa Parker, a human student studying interstellar communications, pushed through the crowd to reach Alex Chun near the front of the observation deck. "How's he doing?" she asked quietly. Better than anyone expected, Alex replied. Look at that framework he's building. It actually looks like it might work. Jake had moved on to constructing the deck platform that would connect his two pontoons. Using smaller logs and pieces of timber, he created a rectangular frame designed to distribute weight evenly across both floats. The metal brackets served as crucial connection points. Clamping onto the pontoons while supporting the crossbeams of the deck, the rope work proved to be the most complex part of the construction. Jake used a traditional lashing pattern his grandfather had taught him, weaving the plant fiber rope through and around the wooden framework in a way that would tighten under stress rather than loosen. Each knot was tied with careful attention to how it would behave when wet and under load. That's actually quite sophisticated, murmured a professor from Centauri Prime, studying Jake's rope work through magnification equipment. The mathematical principles behind those tension patterns are remarkably advanced, even if he's applying them instinctively. Professor Zixthala's mandibles clicked together in annoyance. Instinctive application is not the same as true understanding. Any primitive species can stumble upon effective techniques through trial and error. As the afternoon progressed, Jake's catamaran began to take recognizable shape. The two pontoons lay parallel in the shallow water, connected by a sturdy platform deck that rode about 2 feet above the water surface. The whole structure looked crude compared to the sleek designs common in galactic civilization, but it also looked functional. Jake tested the basic framework by carefully climbing onto the platform. The logs dipped slightly under his weight, but remained stable and buoyant. He bounced gently a few times, checking for weak points in the connections. Everything held firm. Phase 1 complete, he announced to Alex, who had come down from the observation deck to get a closer look. It actually floats, Alex said with obvious relief. I was starting to worry. It floats, but it's not done yet, Jake replied already, moving toward his next task. Now I need to make it move. The mast and sail system would be the most visible part of his construction, and also the most likely to fail if not properly designed. Jake selected a straight branch about 12 feet long and began shaping it into a mast. The polymer sheeting would serve as his sail, but first he needed to create rigging that could handle the wind forces. More aliens continued to arrive throughout the afternoon. The observation deck was now packed beyond capacity with overflow. Crowds gathering on nearby balconies and walkways. What had started as an academic exercise was becoming the most watched event in the university's recent history. Look at the crowd he's drawing, Lisa commented to Alex. Half the campus is here? Professor Zixthala wanted to make an example of him, Alex replied. She just didn't expect the example to be this interesting. Jake worked steadily through the afternoon heat, stopping only occasionally to drink water or check his progress. Against the setting sun? With each completed component, his confidence grew. The catamaran was simple, crude by galactic standards, but it was also solid and seaworthy. As evening approached, Jake stood back to admire his work. The basic vessel was complete: 2 pontoons, a platform deck, and the beginnings of a sail system. Tomorrow would bring the real test, but tonight he could rest knowing that he had built something that looked remarkably like a boat. Not bad for a primitive human, he said to himself, grinning at the thought of Professor Zixthala's reaction when she realized he might actually succeed. The second day dawned bright and clear, with a steady breeze rippling across the lake surface. Jake had spent the night in the simulation area, catching a few hours of sleep beside his half-finished catamaran. He woke before sunrise, knowing that today would determine whether his 24 hours of work had been worthwhile, or simply an elaborate public failure. The observation deck was already filling with spectators as Jake resumed his construction. News of the humans' progress had spread beyond the academic complex. Representatives from other universities, galactic media outlets, and even some government officials had arrived overnight to witness the conclusion of Professor Zixthala's challenge. Jake began the morning by completing his sail system. He stretched the polymer sheeting between 2 horizontal supports attached to his mast, creating a simple but effective rectangular sail. The material was stronger than traditional fabric and completely waterproof, which would help it maintain its shape in strong winds. The sail configuration appears functional, observed Dr. Carricks from the Department of Applied Physics. However, without proper aerodynamic modeling, the human cannot possibly optimize the wind capture efficiency. Jake tested his rigging by pulling on various ropes and checking how the sail responded. Everything moved smoothly, with no binding or unexpected stress points. He had kept the design simple on purpose, knowing that complex systems were more likely to fail during actual use. The steering mechanism came next. Jake carved a large paddle from a piece of flat timber, shaping it into a rudder that could be mounted at the rear of his catamaran. A simple rope and pulley system would allow him to control the rudder's angle from his position at the mast. Alex Chin arrived early, carrying coffee and breakfast from the campus dining hall. You've got about 6 hours left before Professor Zixtala expects you to attempt the crossing, he said. How are you feeling about this? Jake accepted the coffee gratefully and looked at his completed catamaran. The vessel floated peacefully in the shallow water, its 2 pontoons riding high and stable. The platform deck provided plenty of room for 3 passengers, and the mast stood straight and secure. I think it's ready for testing, Jake replied. But I want to make sure everything works before I invite passengers aboard. He waded into the water and carefully climbed onto his catamaran. The pontoons dipped slightly under his weight but remained stable and buoyant. Jake moved around the platform, testing different positions and checking how the vessel responded to shifting loads. The first real test came when Jake raised his sail. The polymer sheeting caught the morning breeze immediately, and the catamaran began moving forward with surprising smoothness. Jake adjusted the rudder, testing how quickly the vessel responded to steering commands. The watching aliens fell silent as Jake's simple boat sailed across the near shore of the lake. The crude construction looked nothing like the sleek designs they were accustomed to, but it was undeniably functional. The catamaran moved efficiently through the water, responding well to both wind and steering input. It actually works, whispered a student from Vega 7, her voice carrying clearly in the morning air. Jake sailed back toward shore, gaining confidence with each maneuver. The catamaran handled beautifully, stable in crosswinds and responsive to rudder adjustments. He practiced several turns and speed changes, learning how his improvised boat behaved under different conditions. Professor Zixtala arrived with the senior faculty, just as Jake was completing his sea trials. Her 4 eyes studied the floating catamaran with obvious surprise. She had expected the human to produce something that barely floated, not a vessel that sailed with apparent competence. The construction appears functional, she admitted grudgingly. However, the true test remains. You must demonstrate that your primitive craft can safely transport 3 individuals across the entire lake in return. Jake lowered his sail and guided the catamaran back to shore. I'm ready for the crossing, Professor. Would you like to be one of my passengers? The suggestion created immediate excitement among the watching crowd. No professor had ever been asked to personally test a student's work, especially work that had been designed as a demonstration of failure. Professor Zixtala's mandibles clicked together as she considered the implications. You want me to trust my safety to that crude assemblage of wood and rope? She asked. I want you to experience firsthand what human engineering can accomplish, Jake replied calmly. If you're not confident in my work, perhaps you could suggest another faculty member who might be willing to participate. Dr. Veltar stepped forward before Professor Zixtala could respond. I will join this test, he announced. As a physicist, I am curious to observe the performance characteristics of such a simple design. Professor Zixtala found herself trapped by her own challenge. She had publicly questioned the effectiveness of human construction methods, and now faced the choice of either backing down or putting her safety where her mouth was. The watching crowd waited in tense silence for her decision. Very well, she said finally. I will participate in your demonstration, Mr. Morrison, but I want it clearly understood that this is being done under protest, and with serious reservations about the safety of your construction. Jake nodded respectfully. Understood, Professor. I appreciate your willingness to help complete the challenge. Lisa Parker pushed through the crowd on the observation deck to reach Alex Chun. This is incredible, she said. Do you realize what's happening here? If Jake succeeds, he's not just winning a bet. He's proving that human approaches to engineering have real value. And if he fails? Alex asked. If he fails, especially with Professor Zixtela aboard, it could set back the human exchange program by decades, Lisa replied. The political implications are huge. Jake made final adjustments to his catamaran, checking every rope and connection one last time. The vessel that had started as a desperate attempt to avoid academic humiliation had become something much more significant. The success or failure of the next hour would influence how humans were perceived throughout galactic civilization. The wind picked up slightly, creating small waves across the lake surface. Jake tested his sail one more time, then turned to face his soon-to-be passengers. Professor Zixtela, Dr. Veltar, whenever you're ready, we can begin the crossing. The moment of truth had arrived. Everything Jake had learned about boats, everything his grandfather had taught him about working with wood and rope, everything he understood about human determination and ingenuity would be put to the ultimate test. The watching crowd held its breath as two alien professors prepared to trust their lives to a human's primitive construction. The lake stretched out before them like a mirror, its surface broken only by gentle waves that caught the afternoon sunlight. Jake stood beside his catamaran, watching as Professor Zixtela and Dr. Veltar approached the water's edge. Both alien professors moved carefully, clearly uncertain about trusting their safety to what they still considered primitive human construction. The crowd on the observation deck had grown throughout the morning. Representatives from dozens of worlds now watched in silence, many recording the event for historical archives. What had begun as a simple academic challenge had evolved into something much larger, a test of whether human engineering deserved respect in galactic civilization. Please step carefully onto the platform, Jake instructed his passengers. The deck is stable, but try to keep your movements slow and controlled until you get used to how the boat responds. Professor Zixtela climbed aboard first, her forearms gripping the rope railings Jake had added for safety. Her compound eyes darted nervously as the pontoons dipped slightly under her weight. Dr. Veltar followed, his tall frame folding awkwardly as he settled onto the platform deck. The vessel seems adequately stable, Dr. Veltar admitted, sounding surprised. I confess I expected more dramatic motion. Jake pushed the catamaran away from shore and climbed aboard in one smooth movement. The boat rode lower in the water, with 3 passengers, but the pontoons maintained their buoyancy perfectly. He had calculated the weight distribution carefully, and his estimates proved accurate. Beginning the crossing now, Jake announced, pulling on the rope that raised his sail. The polymer sheeting caught the afternoon breeze immediately, and the catamaran began moving across the lake with steady, purposeful motion. The simple design that had drawn so much criticism proved its worth in actual use. The twin pontoons provided exceptional stability, while the platform deck offered comfortable space for all 3 passengers. Professor Zixtela gripped her rope railing tightly. As they picked up speed, "How fast are we traveling, Mr. Morrison?" Jake judged their speed by watching the shoreline slide past. "About 8 kilometers per hour, Professor. Fast enough to complete the crossing efficiently, but slow enough to maintain safety and control." The catamaran handled beautifully in the open water. Small waves that might have troubled a single-hulled design passed harmlessly between the pontoons. The vessel tracked straight and true, requiring only minor rudder adjustments to maintain course. Toward the far shore, halfway across the lake, Dr. Veltar began asking technical questions. His scientific curiosity had overcome his initial nervousness about the crossing. "Mr. Morrison, how did you determine the optimal separation distance between your pontoons?" "I didn't calculate it mathematically, Dr. Veltar. I estimated it based on the size of waves I expected to encounter and the length of deck platform I wanted to build." "But how can you achieve structural efficiency without computational modeling?" Jake gestured toward the smooth water flowing past their hull. "Sometimes the most efficient design isn't the one that looks perfect on paper. Dr. Veltar. Sometimes it's the one that actually works in real conditions. Professor Zixtela had been unusually quiet during the first half of the crossing. Now she spoke up, her voice carrying a tone Jake had never heard from her before. Mr. Morrison, I must ask you something directly. How did you know this construction would succeed? Jake considered the question carefully before answering. I didn't know it would succeed, Professor. I believed it would succeed based on my understanding of the materials and my experience with similar designs. But knowledge and belief aren't the same thing as certainty. That seems like a dangerous approach to engineering, Professor Zixtela observed. Maybe it is, Jake admitted. But it's also how humans have been solving problems for thousands of years. We try things, we test them, we improve them. We learn by doing, not just by calculating. The far shore grew larger as they approached. Jake began preparing for the turn that would take them back to their starting point. The return journey would be the real test, sailing against a slightly different wind angle and demonstrating that the catamaran could handle varied conditions. Beginning the return leg, Jake announced, adjusting his rudder and trimming his sail. For the new heading, the catamaran responded smoothly to the course change. If anything, it seemed to handle even better on the return leg, the slight wind shift actually improving the sail's efficiency. Jake found himself relaxing as they sailed back across the lake, confident now that his simple boat would complete the challenge successfully. Dr. Veltar was studying the construction details with obvious interest. The rope work is particularly sophisticated, Mr. Morrison. Did you learn these techniques through formal education? My grandfather taught me, Jake replied. He built boats for 50 years before he retired. He always said that the best engineering came from understanding what you were building, not from trying to make it perfect. Professor Zixtela turned to look directly at Jake, all four of her eyes focusing on him with intense concentration. Mr. Morrison, your vessel demonstrates functional engineering principles, but it lacks the mathematical precision we expect from advanced students. How do you explain this apparent contradiction? Jake guided his catamaran toward the shore where hundreds of aliens waited to see the conclusion of his challenge. With respect, Professor, I think you're asking the wrong question. You didn't ask me to build something that looked impressive on a computer screen. You asked me to build something that works. He secured his sail as they approached shallow water. Sometimes the best engineering isn't about perfect calculations or optimal designs. Sometimes it's about understanding your materials, recognizing what's actually possible, and having the practical skills to make it happen. The catamaran's pontoons touched bottom gently as they reached the shore. Jake jumped into the shallow water and helped his passengers step safely onto dry land. The crossing had taken just over an hour, completed without incident or danger. The crowd on the observation deck erupted in cheers and applause. Many of the alien students seemed genuinely impressed by what they had witnessed. The simple human construction had not only worked, but had worked well, safely transporting 3 individuals across the lake and back exactly as challenged. Professor Zixtela stood on the shore for several minutes, staring at the catamaran that bobbed peacefully in the shallow water. When she finally spoke, her voice carried clearly across the area. Mr. Morrison, you have successfully completed the challenge as specified. Your vessel has proven functional and safe. She paused, her mandibles clicking together in deep thought. I believe this demonstration requires significant revision to our current curriculum. Jake secured his boat and faced the assembled crowd. Thank you, Professor. I hope this shows that human approaches to engineering can complement the advanced theoretical knowledge taught here. We may not always calculate everything perfectly, but we know how to build things that work. 6 months later, the Galactic Academic Exchange announced major changes to its engineering curriculum. Practical construction courses became mandatory for all students, taught by instructors from species known for hands-on building techniques. Jake's simple catamaran was permanently displayed in the University Museum, bearing a plaque that read, "Sometimes the best engineering is simply engineering that works." The human exchange program expanded dramatically, with universities across the galaxy requesting students who could teach practical problem-solving techniques alongside theoretical knowledge. Jake Morrison had proven that humanity deserved a place among the stars, not because humans were the smartest or most advanced, but because they knew how to take an idea and make it real.